LLaMA 3 Day has arrived and it's thrilling. Today we'll dive deep into LLaMA 3. We'll cover the announcement, explore what's new and different, and I prepared a series of videos for you that include testing, coding, and fine-tuning LLaMA 3. These are exciting times. If you haven't subscribed yet, make sure to do so to keep receiving fantastic AI content. Let's get started.
So today, we're open sourcing the first set of our LLaMA 3 models at 8 billion and 70 billion parameters. They have best-in-class performance for their scale. And we've also got a lot more releases coming soon that are going to bring multimodality and bigger context windows. We're also still training a larger dense model with more than 400 billion parameters.
So just a few minutes ago, we had the launch of LLaMA 3. This is the third version of the LLaMA series of models out of Meta AI, and taking a step back, the original LLaMA leak, which was about a year ago, was really what set off the entire open source locally run model craze, and I am so thankful to Meta and whoever leaked it, because it got an entire new generation of people into artificial intelligence. And then we had LLaMA 2, which was a huge upgrade from LLaMA 1, and now today we have LLaMA 3. So let me show you what it's all about. This blog post is titled "Build the Future of AI with Meta LLaMA 3. You can access, download, and explore everything about the models at llama.meta.com/LLaMA 3. LLaMA 3 is now available in both 8 billion and 70 billion pre-trained and instruction-tuned versions, catering to a broad spectrum of applications. For those of you with a sharp eye, you might have noticed the absence of a mid-sized model, typically around 34 billion parameters. It's likely on its way. Interestingly, it appears that Meta AI has launched, or perhaps I wasn't aware before, a competitor to the ChatGPT UI. We'll have the opportunity to try it out here, and I'll conduct a few quick tests to demonstrate its capabilities. However, I'll save a comprehensive set of tests for another video. It's noteworthy that they mention this right here. Whether you're developing agents or other AI-powered applications, these models provide the capabilities and flexibility essential for bringing your ideas to life. Agents have now become first-class citizens in the world of AI. Previously, many doubted the significance of agents, dismissing them as merely prompts. However, they are much more than that, and I'm pleased that Meta recognizes and acknowledges their importance. Here we are at Meta AI's new chat interface for LLaMA 3, accessible at meta.ai. Be sure to stay tuned for my upcoming videos where I'll conduct the full suite of tests on this model. If you're eager to try it yourself, simply visit meta.ai, where they now have their own inference front end, which is pretty amazing. All right, let's continue to see what enhanced performance features they've introduced. Enhanced state-of-the-art performance of LLaMA 3, an openly accessible model that excels at language nuances, contextual understanding, and complex tasks like translation and dialogue generation. With enhanced scalability and performance, LLaMA 3 can handle multi-step tasks effortlessly, while our refined post-training processes significantly lowers false refusal rates, improve response alignment, and boost diversity in model answers. This is all very promising. I'm particularly excited about the effortless handling of multi-step tasks, which really highlights the capabilities of AI agents. This aligns perfectly with my plans to integrate this into Crew AI. Additionally, it significantly enhances features such as reasoning, code generation, and instruction following. They even provide a model download link right on the site. By clicking it, you can request access by entering your information. With these advancements, there seems little reason to go back to LLaMA 2. I'm eagerly anticipating the upgrade of Metacode LLaMA to be based on LLaMA 3. Just imagine the possibilities once you download it. And here are the benchmarks so LLaMA 3 models take data and scale to new heights. It's been trained on our two recently announced custom-built 24,000 GPU clusters on over 15 trillion tokens of data, a training dataset 7 times larger than that used for LLaMA 2, including 4 times more code. I love the coding use case. I'm so glad that they're using a lot more code. Obviously, it's really good. I just tested it with Snake and it got it on the first try. This results in the most capable LLaMA model yet, which supports 8K context length, and that doubles the capacity of LLaMA 2. Indeed, 8K tokens might seem small when compared to the larger capacities we're seeing nowadays, like GPT-4's 128K, or even the massive 1 million tokens of Gemini Pro 1.5. We're becoming somewhat desensitized to our token limits. While 8K is modest, the fine-tuned versions could significantly expand this, and hopefully they maintain high quality. The benchmarks are interesting. They compare the 8 billion parameter version of this model to Google's Gemma 7 billion, which is a smaller open model, and Mistral 7 billion Instruct, which is always one of my favorites, if not the favorite. It's fascinating to see how these models stack up in real-world applications. But Meta's LLaMA 3.8 billion is emerging as the clear winner among these smaller models, especially notable in benchmarks like the MLU5 shot, where it scores 78.4, significantly outperforming its competitors with scores of 53 and 58. In a zero-shot comparison, GPQA34 outperforms both 21 and 26 in a range of benchmarks including Humanival, GSM-8K, and mathematics. Notably, LLaMA 3's math scores are 3 times higher than those of Gemma 7 billion and Mistral 7 billion Instruct. Given this, it seems wise to include more complex math questions in my LLM rubric. If you have any suggestions, please share them in the comments below, and I'll consider adding them. Then there's the large model, and here's something interesting. Meta chose to compare their sizable 70 billion model with Gemini Pro 1.5, which is a closed-source model from Google, considered their most advanced. This model includes a 1,000,000-token context window. They also compared it to Claude 3 Sonnet, but not to Claude 3 Opus, which is widely acknowledged as the top model available, whether open or closed source. It's noteworthy that they only compared it against Claude 3 Sonnet, as this model is considered the intermediate option among the 3 Claude models. In the MLU5 shot challenge, it barely won, whereas in the GPQA, it nearly lost. However, it performs significantly better in the Humanival, which focuses on code generation, just as a reminder. Check this out, LLaMA 38 billion's code generation capability is twice that of both Gemma 7 billion and Mistral 7 billion. Meanwhile, for LLaMA 370 billion, the Humanival score is nearly 82, compared to 71 for Gemini Pro and 73 for Claude 3 Sonnet. They've clearly prioritized the coding capabilities in this model, which excites me since that's my preferred use case. This likely indicates strong performance in function calling as well. In the GSM-8K, it ranks first, but in the math benchmark, its score of 50 is actually a bit lower than Gemini Pro 1.5's, yet still considerably higher than Claude 3 Sonnets. We're going to discuss trust and safety, which is a major focus for Meta, particularly as they're making all of this open source. They are keen to ensure responsible usage, whatever that entails. Let's explore some of their latest innovations in the trust and safety area. With the launch of LLaMA 3, we have revised the Responsible Use Guide rug to offer the most detailed information on responsible development with LMS. Our system-centric approach now includes enhancements to our trust and safety tools with LLaR 2. Interestingly, I hadn't heard about LLaR before, but it's now optimized to align with the new taxonomy released by ML Commons. This update extends its reach to include a broader range of safety categories, such as Code Shield and CyberSec Eval 2. LLaMA Guard is about making safety tools available to everyone, thus enabling developers to enhance safety and contribute to an open ecosystem. Essentially, LLaMA Guard serves as the framework designed to ensure that models are used appropriately. Let's delve into what it entails. The stages of responsible LLM product development begin with determining the use case. Next is the model level, where the actual creation of the model takes place. This is followed by the system level, where tools like LLaMA Guard 2 and LLaMA Code Shield are implemented. Finally, there is a focus on building transparency, introducing LLaMA CyberSec Eval, which essentially assesses the presence of insecure coding practices, the potential aid to cyber attackers, misuse of code interpreters, offensive cybersecurity capabilities, and vulnerability to prompt injections. It will be interesting to see how this last aspect pans out, given the recent success of jailbreaking techniques that have significantly disrupted both cutting-edge closed and open-source models. There's a detailed paper on this topic, but I won't delve into that now. If you're interested in exploring it further, let me know in the comments below. Meta AI is a fresh launch, available at meta.ai, serving as the interface to their inference engine. Essentially, it's competing with ChatGPT, and it's currently free to use. Thanks to our recent advancements with Meta LLaMA 3, we believe that Meta AI is now the most intelligent AI system available at no cost. Their ongoing releases into the open source community represent a strategic defensive move in the competitive landscape, which I truly believe. By continuously offering their technology for free, they increase the pressure on closed models like GPT-4, Claude, and Gemini, potentially driving down costs, which benefits both developers and users. I've also mentioned before how quickly models are becoming commoditized. In a previous video, we discussed extensively about the AI stack and where the real value lies. At the foundation, there's the hardware layer occupied by entities like NVIDIA and Grok, where significant value is being generated. However, initiating projects in this layer likely required starting several years ago. Above that is the infrastructure layer, which includes agent orchestration tools, evaluation tools, deployment solutions, and observability. This layer is poised to create substantial value. Next, we have the model layer, where I believe there won't be much value in the long term. At the very top is the application layer, which includes apps developed with AI or traditional apps that have integrated AI features. I do think this layer will hold a lot of value, although we haven't fully seen this materialize yet. Meta AI can be utilized within chats, searches, and more across our apps, enabling users to accomplish tasks and access real-time information without exiting the app. What I believe they still need to do, which hasn't been done yet but likely will be, is to begin integrating all the user context from their systems into LLaMA 3. Rather than always being a stateless engine, it should be capable of answering questions related to the content on the page, my chat history, and past activities. That's the aspect I'm truly enthusiastic about. Additionally, Meta AI's image generation has become faster, now producing images as you type. This allows you to quickly create album artwork for your band or find inspiration for home decor. I wasn't aware that you could create images with Meta AI, so I decided to test it by asking it to generate an image of a robotic llama, and yes, it did produce one, which is pretty impressive. I usually use DALL-E for image generation and have been quite satisfied with it. While the quality from Meta AI isn't as high as DALL-E's, it's still quite good. Notably, all their AI-generated images include an imagined watermark. Yes, you can now use Meta AI. It's readily available on your smartphone and it's free. It's becoming global with additional functionalities that you can utilize on Facebook, Instagram, WhatsApp, and Messenger. They are really pushing to enable users to get things done, learn, create, and connect with what's important to them. Meta AI has been launched in English in over a dozen countries beyond the US, including Australia, Canada, Ghana, Jamaica, Malawi, New Zealand, Nigeria, Pakistan, Singapore, South Africa, Uganda, Zambia, and Zimbabwe, and this is just the beginning. Here's how it works. If you're planning a night out with friends, you can ask Meta AI to suggest a restaurant that offers sunset views and vegan options. It seems it does already utilize external context. How exciting. Ooh. Or if you're organizing a weekend getaway, you can have Meta AI find concerts happening on Saturday night. You can see these examples in action right now. In the Messenger app, you simply ask a question and immediately Meta AI provides the needed information right there. Just tag Meta AI, ask your questions, and it responds. Very cool indeed. LLaMA 3 Meta AI is also integrated into search, marking a major rollout for Meta. For instance, you can ask it to show a video of a recipe. These are some impressive examples. Oh wow, they've even incorporated it into your feed. I'm not a big Facebook user, actually. I hardly use Facebook at all, but now Meta AI is embedded directly in the feed, the core product that drives their major revenue. It's fascinating to see Meta's deep commitment to AI, particularly with LLaMA 3. This signals to developers that LLaMA 3 could be a great platform for building AI apps. For example, you can ask it to imagine a bird and it will generate an image of a bird. Then, if you say animate, it actually animates the image, which is quite impressive. While I think the quality of the images isn't quite on par with those from DALL-E or Midjourney, the fact that it's free is a significant advantage. Moreover, simply commanding Meta to animate transforms the image into a GIF that you can share. The GitHub page for Meta LLaMA is now available, where they have indeed posted the code for LLaMA 3. You can download the models there, though I believe the original weights aren't open yet. At least I haven't seen any indication that they are. This means while the code is open source and you can download and modify the model, the foundational weights might not be released. If you're interested in exploring this further, the GitHub repository is accessible at github.com/metalama/llama3. Here's the model card for it, and it will probably be available on Hugging Face soon if it isn't already. The model boasts a staggering 15 trillion token count, which is incredibly high. Despite this vast input, the model is distilled down to a size comparable to its predecessor, LLaMA 2. So it's now an 8 billion model instead of 7 billion with 70 billion parameters. Here are various benchmarks comparing LLaMA 2 7 billion, LLaMA 2 13 billion, and LLaMA 3 8 billion models. Interestingly, across all benchmarks, LLaMA 3 8 billion outperforms LLaMA 2. Then there's LLaMA 3 70 billion, which shows a significant improvement over the LLaMA 2 70 billion model, once again performing better across the board. I'm incredibly excited to put LLaMA 3 through its paces once I finish this video. I'll be testing it thoroughly against my LLM rubric. If you enjoyed this video, please consider giving it a like and subscribing. Stay tuned for the next one.